Okay, so we're going to talk about two learning targets together, and it's going to have kind of a lot of concepts. So, but they all kind of are connected. So that's why we're going to spend hopefully a block day on this. So, f of x divided by g of x. So we're just going to be talking about dividing two polynomials equals q of x. So think of that kind of like the quotient with the remainder r of x. Okay, so let's talk about numbers to kind of help you understand this, because this seems really confusing altogether. So let's say we were doing 20 divided by 3 equals 6, because 3 goes into 26 times, with remainder 18, that'd be 2, remainder 2. Okay, then what that means is 20 is equal to 3 times 6 plus 2. Basically, 3 times 6 plus 2 equals 20. We already know that that's true. So this is kind of the basics of polynomial division. Actually, go ahead and write those down in case this kind of gets confusing for you. But basically, dividing two polynomials, you're going to get another polynomial and sometimes a remainder. So that means that the original polynomial that you divided is equal to the one you divided by times the quotient plus the remainder. Okay? So we're going to write our answers that way when we do polynomial division, so that we can keep track of how the different polynomials are related. So we're going to talk about using long division. So if you need help with long division, I would pause the video and I'd go over to Khan Academy and learn how to do it, because you're going to have to know how to do long division to be able to do division of polynomials. So we're going to put 2x squared minus 5x minus 1 divided by x minus 3. Now you might run out of room. I know I won't, but if you need to, you might grab another piece of paper here. So basically what we're going to do is we're going to figure out a way to get x times what will equal 2x squared. So x times 2x will get you 2x squared. So I'm going to multiply 2x by x minus 3 and write the answer under here. So 2x times x gets me my 2x squared. 2x times minus 3 is minus 6x. So the basic idea here is I want to find what is going to multiply by x minus 3 to get rid of this first term here. So 2x times x equals 2x squared. So just like in long division, I'm going to subtract what I've got. So this will get me nothing. Negative 5 minus negative 6 will actually be plus a positive 6, so I'll have 1x, and then I'll carry down the minus 1. Now I want to figure out what times x will get me 1x. So obviously 1, right? So I'm going to do plus 1, and I'm going to multiply that by x minus 3. So 1 times x is 1x. 1 times minus 3 is minus 3. Then I'm going to subtract these. 1x minus 1x goes away. Negative 1 minus negative 3 equals positive 2. So then writing this as written up here, the original polynomial 2x squared minus 5x minus 1 is equal to the product of 2x plus 1 times x minus 3 with the remainder of 2 added on to the end. Okay? Another way to do this is with synthetic division. It takes up a lot less room. It's the same basic idea as what you're doing over here, but it's kind of written in shorthand. So it's going to be a quick way to do long division. I want you to learn both methods, because I think conceptually long division is going to help you understand what's going on, and then synthetic division will actually help you go more quickly and to be able to do this fast and taking up less room. So what you're going to do is you're going to draw an upside down division, and then right across here, the top part of that, you're going to write the coefficients of all of your polynomial that you're dividing. So 2, negative 5, and negative 1. You're going to write those in order from largest to smallest, and you're going to put a 0 in if you're missing a term, which we'll see later. And then over here, you're going to put the 3, which is the root that you're dividing by. X minus 3 is a root of positive 3, so that's why I put a positive 3 here. So here's how synthetic division works. I'm just going to bring down the 2. You always bring down the first term. Then I'm going to multiply 3 times 2 and put the product here. So 3 times 2 is 6. Then I'm going to add these together. Negative 5 plus 6 is 1. And then I'm going to do the same thing that I did last time. I'm going to do 3 times 1 and write the product over here, which is 3. Then I'm going to add negative 1 plus 3, which is 2. And then I'm going to take, and I'll write my answer the same way and say that my original one, 2x squared minus 5x minus 1, is equal to x minus 3, which was my original thing I was dividing by. And then I'm going to take, and I'm going to take the first, or take all of the terms except for the last one. This one right here is always your remainder. And I'm going to just take the degree down by 1. So this was a 2x squared, so this is a 2x. And then plus 1. And then plus my remainder 2. Okay? So it's the same exact idea, and it's just getting the hang of it over here will help you to do synthetic division more quickly later. So the reason that this is useful is I want to find the roots of this function. I see the graph and I see that we have one nice root, okay, at negative 2, 0, which means I know one of the factors is x plus 2, okay? So I can divide that out of my polynomial. So I'm going to set up a division problem and take my polynomial. I'm going to do long division this time, although if you were feeling more comfortable at this point, you could do synthetic division, and I'm going to divide out my root. Now what's going to happen in this case is we're not going to have a remainder because this is a factor of this polynomial, which means there will be a 0 remainder, which you'll see here in a second. So x times 15x squared, those two will get me 15x cubed. And then I also have to multiply this by 2 here. So I'm going to subtract. Those will go away. 16 minus 30 is negative 14x squared. And then I'm going to bring down the rest of my polynomial. Now I'm going to figure out x times what will get me negative 14x squared. So minus 14x. That will give me negative 14x squared minus 28x. I'm going to subtract those. These will go away. Negative 36 minus negative 28 gives me negative 8x. And then I'll bring down the negative 16. Okay, and then lastly, x times what will give me negative 8x? That'd be minus 8. So negative 8x, and then negative 8 times 2 gives me my minus 16. And like I said, there's no remainder because this is a factor of this. So what I can say is my original function is equal to x plus 2 times 15x squared minus 14x minus 8. So I've basically factored one term out and gotten here what's left over by dividing. And there's no remainder at the end, so this is equivalent to this. Now all I need to do is find these remaining two roots here by applying the quadratic formula. So I would use 15 for A, negative 14 for B, and negative 8 for C, and then I would plug those into the formula and I'd find my other two roots. Okay, so if I can get this down to a factor or multiple factors times a quadratic, then I know the quadratic formula will always work to help me out. I'm not going to do that in this video because I want to get going here, but you could finish that problem if you wanted to. And then lastly, the remainder theorem. This theorem says that when you divide a polynomial by x minus c, so by a linear root here, x minus c, then the remainder r will be f evaluated at c. So in other words, here, if I have a function and I want to evaluate it for g of 2, meaning I want to know what happens when I put 2 in for x. I can use polynomial division to help me do that quickly. So one way you could do it is just go through and find the answer to this here. But the remainder theorem helps us do something more quickly, which is to divide negative 5x to the fourth plus x to the third minus 3x plus 10, to divide it by x minus the number that you're trying to evaluate at. And this is where, when you can do synthetic division quickly, it's actually much faster to divide by 2 to divide that synthetically out of your polynomial. So I'm going to write the coefficient of x to the fourth, the coefficient of x to the third. Now notice there's no x squared term, so really in here there's a 0x squared, which is what I was talking about. You're going to need to put a 0 placeholder there, then negative 3 and 10. And then quickly going through a synthetic division, I bring down my negative 5. 2 times negative 5 is negative 10. Add those, we've got negative 9. 2 times negative 9 is negative 18. Add that to 0. 2 times negative 18 is negative 36. Add that to the negative 3. Got negative 39. 2 times negative 39 equals negative 68. Add that, negative 78. Add that to 10 and I get negative 68. Right here is my remainder, which is the solution for g of 2. So meaning if you plug 2 into x here in this function, you would get negative 68 out. So g of 2 equals negative 68. And that's the basics of the remainder theorem.